Hello. Right. Just gonna kick on. I've been doing some more work actually, just in the meantime cleaning up some things. So last time I was showing the cube map basic test at the moment. I implemented this texture 2D array with animations, and uh, I've added this 3D texture. So this is a sign distance field that was pre-calculated. That's on. It comes from my other code base, actually, my C++ engine. So it was generated for a sign distance field shadows sample. See, it's got the Stanford bunny, a stack of blocks. This is a dinosaur mesh. High poly meshes that have been baked into a sign distance field. So the code for calculating the sign distance field is called SDF-gen. It's on GitHub. It's a repository by Christopher Batty. And I think some of the code came from Robert Brinston. So that's a C++ kind of algorithm that does this. I sort of modified it slightly to input my kind of data into it and things like that. But I'm gonna I might look at some point at porting that to a compute shader, trying to do a real-time sign distance field generation. So I also was able to nick some code from my other code base, and because it's HLSL, things are moving pretty quickly because of the similarities, really. So I already had the algorithm and the code for like ray marching the sign distance field to visualize it. I'll give a quick demo of how that's looking. It's in the debug HLSL shader. I've got changes in there. Let's see. They compiled fine. So textured 3D test. Basically, it's a array march through a distance field, and I was able to hook that up fairly quickly. There was a small bit of stuff I had to do in order to get the 3D texture working. Just a small amount of the upload texture function again, just modifying that to make sure it properly worked out the size of data that needed to be copied. And I had to do also a weird, I had to hack. I did it in Python, but here was the original DDS SDS shadow.dds flags did not have the depth flag set, so I'm using it's called DDS file in Rust from crates.io, and it basically set the depth to 1 if the depth flag wasn't set, even though in the original source file, the STF shadow, which was generated in my old engine and written out, even though the there was 128 depth, there's 128 like layers in the 3D texture. So in Python, I was able to just kind of extract that little flag. This is the flag that's like the third U32 inside the DDS, and then I just overwrit it. So I couldn't be bothered sort of going through and figuring out how to save this out again, because you need to generate it. But anyway, I'm pretty happy how quickly that went. I did have to do a bit of work in order to get this working in my shader compiler. So I sort of touched on it last time about here are a bunch of different resources: texture 2Ds, cube maps, texture 2D arrays, and 3D volume textures. And these can all be aliasing the same register, and we can sample them if we bind a heap. In order to do that, so in a descriptor layout, this is the sort of metadata that's generated by pmfx that goes along with a shader. The descriptor layout has bindings. So this one just has a binding on shader register 0. Let's see what other bindings I've got in here. I thought that maybe I have something with, so this one's got multiple, 2 constant buffers. and they are, oh no, they're push constants. That's no binding, sorry, I've got selected. At the moment, I've only got, what shader was I in then? If I could just orientate myself, get to the 3D texture shader. Oh my god. Texture 3D, right? Texture 3D test, render graph. So the one vertex, here we go. So texture 3D has one binding. It's a shader register 0 of type shader resource. And that could be a 3D texture, but if I go into the shader code, it also brings in, this is effectively the same as sampling from a texture. I'm not using normal textures, which is texture 2Ds, but I could use texture arrays. And they're also on slot 0. So I had to fix this because what was happening is it would effectively go, you've got two kind of resources on shader register 0. So I've just been fixing that up and doing a few other bits in the shader compiler just to kind of speed things along, and it was a bit of fiddling around and debugging with some problems with Python. I was actually writing quite functional code, but dictionaries are mutable, so it was like a mutable dictionary inside a functional kind of approach, which caused some problems. So that's now fixed, and can start to see how things might shape up, because essentially what I can do is go, all the textures just get bound in one big heap, and then we can index into them, and we don't have to bind textures anymore. What I'm starting to see is that you can have a C buffer, right? This is C buffer, it's on register B1, so I'm just going to make another one, C buffer test. And this is what I need to figure out. I'm going to put this on B0. And what I'm wondering is, how can I alias constant buffers along with the textures as well? And so if I bring in, what do I call it, C buffer test. Okay, so it's got an error. Shader register type CBV, root parameter 2, visibility pixel, descriptor table slot 0 overlaps with another shader register range, which is visibility all. So in my test JSON now, the texture 3D, since I added that, that doesn't seem right. That's not been reloaded. Let me double check as well. Yeah, so they're the things I've done. I fixed up the fact that cube maps and textures and stuff weren't quite working in terms of that metadata generation in the descriptor set. But if I open tests.json now, texture 3D, here we go. Right, so we've got two bindings. One is a constant buffer and one is a shader resource. Now, can a shader resource type, can a constant buffer also be a shader resource type? That's what I'm wondering. And I don't actually sample from the buffer, but if I don't build and I just make this local modification, I'm just going to see what happens. What I'm trying to do is figure out here, how would I handle this in a material system essentially, and that's my main objective. Like I started this week wanting to get materials working, and they kind of are, or in some way they are. So now I'm not sampling from the constant buffer, but see, the constant buffer could be treated for just push constants, and then the other constant buffers could be treated as shader resources. Or having said that, I'm trying to think of what uses it. There's the example, which is, I think it's in debug. So I'm not using constant buffers much. I'm using push constants, which you use C buffers for in HLSL. But what I'm not using is like kind of materials. The only place I am using it is in this C buffer instance, which uses C buffer to supply the indices, and that one is in debug.json. So C buffer instanced. So that's the pipeline is called mesh debug C buffer instanced, and this descriptor layout has a constant buffer binding on visibility vertex. Now, what I'm wondering is why that distinction is different. So shader resource, I called it. That's a shader resource view. We have a constant buffer view, I think. I think there's a constant buffer view, which means that they might have to be different. So in order to sort of debug this, I'm just gonna look at the graphics API and kind of follow through from there. And the plan is to sort of figure out in a sort of how's this going to work. I think my initial thinking is that meshes will have a material ID in the vertex buffer, and then they can be drawn with instancing. So like a mesh is very basic vertex format. The vertex format would be position, normal, text coords, so on, and they will have material ID. And then the material system is completely deferred, so you can get away with, you can kind of do single draw call for the whole scene, and then start investigating into how you would do mesh selection in that way, because you could draw all the same, all the things that have the same mesh in a single draw call. I believe you can change the vertex buffer from a execute indirect, and that's what I'm going to start looking at soon. So this is kind of just a bit of I'm just kind of looking through this and mulling it over. Shader resource, textures or structured buffers are shader resources. C buffers. So I wonder why I would ever use a C buffer instead of a structured buffer. Which is an interesting thought. And then, so they're the type of descriptors. I mean, the terminology around all of this, descriptors, descriptor sets, and bindings, Method calls it argument buffers. It's quite confusing to really sort of build a mental model of what everything's doing. So shader resource, create a shader resource view. Vertex constant buffer, vertex. So vertex and constant buffer has the same. Oh no, that's a resource state. Shader resource CBV. And so, yeah, so I don't know why I would favor using, like, traditionally I would have always used a C buffer to do like the lighting, you know, to put all your lights in a C buffer, put all your like material properties in C buffers, put all your matrices in C buffers. But now maybe I would use a structured buffer. So that's kind of where I'm at with this at the moment. Let's think. So the next step was I made this basic one, which is really more like it's just using a texture. C buffer push constants are pushed into the buffer, into the pipe command buffer, and they can index into select a texture. I probably should do some different textures on these just to kind of highlight that they are, you know, they are different. And it's not really a material. It's just a kind of like push constants texture lookup, which the same thing is used in the cube map, and the same thing is used in the texture 2D array. So they're kind of, that's already working. The next thing to do would be to create a material, and the material is going to be made of kind of a lookup, and I really need some lighting, so I'm just going to have a look at the to-do list and see what was on the list. Unify shader and pmtech code. I did tidy that up a bit, so I'm going to say that's done for now. It does need another pass, but I believe that I can actually maybe get away with using might do that now, a single function. So last time I was sort of messing around, I had a bunch of vertex shader functions. Oh yeah, the texture 3D has its own vertex shader, but VS mesh and there's a so VS mesh push constant material. That's essentially, if we output material color in here instead of that, I'm just doing this to kind of consolidate the existing code. So let's have a look at the usage of VS mesh push constants material. Doesn't seem to be used in many places. Should be in the debug VS mesh push constants material. The search is not finding it. Certain results in 4 files. So they've gone black now because I just changed them to use the material color. And so I think instead of doing that, because I'm already passing through the text coord in the mesh debug shader PS checkerboard, I'm just going to change the output color to be input text, no, input normal. So this is what it was doing before, effectively. There we go. So now basically there's only one. These are identical, and I don't know why I couldn't search and find this string. But we can just replace everything with VS Mesh. Or at this point, it might be easier to do it the other way around. VS Mesh, push constants material, VS Mesh, push constants material, VS Mesh, push constants material. And then I can get rid of the VS Mesh function and just kind of keep these, minimize the code duplication. And just check all of these are working now. Draw push constants material states. Oh, blend states have now broken. They must be using VS Mesh. Touchy 2D array is fine. Touchy 3D is fine. And that's it. So test blend states. Black. So what was happening before, there was a couple of structures in here that had, some had a color, some had textures, and I just put them all in one. That was because originally I had more camera matrices and I didn't have enough room for as many push constants as I wanted. So it made it a bit messy, and I managed to tidy that up. And I think I'll go with quite a small amount of push constants and then look up more information from C buffers. So that's kind of my plan to do next. Let's see. I think it was the draw file. It already had some materials. So I started on this material where, I mean, this is actually fine. But what was happening is you get a material instance. So there'd be one, oh yeah, here we go. This was my original like little notes. Draw C buffer per entity, which contains a world matrix and a material ID. Then we have a C buffer per material, which has the stuff in. Load textures in the ECS. So I think I've already done that part. So the plan was the material instance could be pushed as push constants, but instead of it being the albedo texture, the normal texture, it's just one single ID, and then that ID looks up into another C buffer which contains albedo, normal, roughness, metalness, color, whatever, and then you can kind of reuse and share similar materials. Obviously you might have lots of different materials, but you're probably going to end up, then you're probably going to end up reusing materials in a general case. So that made me think that the existing sample, instead of it being push constants material, it should just be push constants texture. And then the real material systems becomes a bit more complex, and I already have a texture component which is just, they're at the top here actually, or are they? No, somewhere else. It's in tests.rs. No, that's the wrong one. The wrong tests. This one, plugins. It's in plugins. There's a texture instance, which is just a U32, and a texture component. And they're not kind of material based. These are maybe kind of useful, reusable components that I could move back into the core ECS system so they can be reused potentially. But first, I'm just going to see why this is broken, the blend states. So blend states, render meshes pipeline, colored, and let's see what blend states. VS mesh push constants material. So let's check. So I don't really understand why that. It was working to begin with, and then now I changed this shader to really only affect the primitive sample, which is working. Pipeline colored. So we have a world matrix, which is 12, and then a color. I hate when this happens, when like you just you know, everything's working and then all of a sudden something's broken for no particular, you know, you don't know why, when it broke, and then you sort of you're kind of dwelling on that existing code that you already thought was working. Like previously, material color, is that correct? Material color is the second thing in the buffer. Let's just set this to a hard-coded value. Get the most out of the right, okay, so it's using this shader that's set it to magenta. The material color is the, so there's 12 floats, and then I need a better system for setting the push constants and doing the offsets. Still ironing that out. So now it goes to black, and then in the pipeline that it's using, render meshes pipeline colored. Hold on. Raster meshes, blend meshes. Render grid, render meshes pipeline. It's hard to link these guys together. Like the actual, one of them is the name of the function they call, and one of the name is name of the view, and that's causing me confusion now. Just gonna close these kind of debug things. PMFX, so it is in test PMFX. They all inherit from the same thing. We know that we're using VS mesh push constant material and put that. I know what it might be. has the name of the push constants changed? No, because they still have the world matrix. So blend test, render meshes, pipeline colored, blend meshes. Raster meshes. I don't think that should be inheriting. I went to inherit from the other one, and that's just made it confusing. Blend test, grid, blend, meshes. Raster test, grid, raster, meshes. Cube map test. They're all working all right, but they must have, everything's going to have extra. Right, it's working now. So that's one of the dangers with some of the inheriting of the state. It can become it's powerful, but it can quickly kind of become a bit misleading. So an example that I've only just realized this is happening now. On the test cube map, we're rendering cube map test and also render meshes pipeline, and we're drawing raster meshes because I thought, oh, I'm going to inherit from these things. And the reason I did that is that I wanted to rename these things. And if they were called the same thing, then it would be fine because the inheritance would overwrite it. But because I changed the names of them, I mean, that's not sphere meshes. This should be billboard meshes. Just to make it a bit more clear. Texture 3D Tesh, SDF, meshes. So now, in the render graph, there is a render grid, a render meshes, cube map test, and in the texture 2D array, we've got render graph, render meshes pipeline. This one still has two. It's inheriting, so I'm just reverting changes I made earlier, basically. So now we render grid, render meshes, texture 2D array test. That's the function name. And then in the command queue, the view name is grid and build form meshes. So it's these two. One of them's in the render graph, which is the function that gets called, and one of them is in the command queue. And what I think I need to do is add that information in here just to make it a bit clearer, because it's a little bit confusing. So right, so now back to kind of square one, not square one, but back to parity. Everything's working. Okay. So I think my push constants material should actually be called draw push constants texture, and rename kind of some of the stuff associated around that. And that is in the draw test. The draw, set up draw push constants material. I'm not sure why this search was broken. So this has got, right, this has found them. So I'm just renaming this kind of as I go along before the next phase, just to kind of really make things consistent and clear. So instead of it being mesh push constants material, which is the material name, I'm going to call it mesh push constants textured, because I don't see the value in making this a full material and doing normal mapping and everything. I'm going to do that by the C buffer material system, and that sort of came about because of, as seeing this take shape, I sort of started to realize this would probably be a better way to do it. So the mesh push constants material mesh, and essentially these are a test. Again, I've got the little bit of confusion about the code split across a couple of files. And that one, VS mesh push constants material. Material color, draw indices. See that in that case, I'm just going to call it VS mesh push constants. It's crashed, reloaded. I fixed a few bugs actually yesterday after I finished the stream, when it was crashing on like adding new pipelines and like reloading them. So I think it's feeling a bit more stable today. I've not run into as many problems. Most of my problems come with this thing where I was trying to bind these guys on the same. That was still there. So I manually edited that file. So the C buffer testing, if I try and bind that, it crashes. There's also another issue where these are on T0, but when you bind the heap, you bind it on the slot that's active on the what's it called, the root signature. So that's another thing I want to kind of look into. I feel like I've sort of jumped all over the place here, and I'm just thinking out loud, just trying to look through the code, distill it down, simplify it, and refactor. And I suppose maybe to sort of highlight this, that this is kind of how I work. I'll do this a lot, just sort of evaluate things, experiment, and I'm always trying to get the smallest amount of code that does the maximum impact, essentially. But now I'm not going to worry about those, and I'll show shortly the kind of the root signature. Is it called root signature? We'll have a look at that. But I'm probably going to head off shortly, and this is just a short session. Right, so we've got VS Mesh push constants, and everything uses that. Then there's no real mention about material. We've got some push constants in there. It's not really a material. It's just they're called draw push constants, and we're sort of using them in the vertex shader. And then we've got PS Mesh push constants material. Now this is what's not a material. This is just texture. So I'm going to go. And that's kind of a handy one that could be reusable. That, you know, you just want to sample a single texture and you want to pass the index to it through a push constant, draw indices y, and we make it draw indices x. And I think I'll just go with the albedo here instead of the normal map. It looks a bit nicer. And while I'm here, I think I'll go to the draw test and I'll make everything spheres. They kind of look a bit more. And we don't even need to do that. No need to create unnecessary so we got a clone. Meshes. Where's meshes? Oh. We know that, we just want 9 of them. IRC meshes.length. Rows, columns. No, it's 3. And we don't even need this little bit. No need for that. Oop. Right. Still failing. Mut I. It can't be failing for that reason, can it? Well, okay. And then, so the point of this one is to maybe just demonstrate a bindless texture approach. So instead of loading a material, it makes sense to load a few different textures and use the texture component, which is actually in the other crate. Test.rs. That's the wrong one. Get rid of that test.rs. That's the one I want. This is the one I don't want. Okay, so texture instance and texture component. Time component and animated texture component. Really, I think these are kind of useful ones, all of them, that I'm going to just bite the bullet, close the hot reload environment and just put them in the core ECS. So here's the ECS base. This has the resources like the time, PMFX device, app, main window. That's what you can pass to the systems. And then you have components. This camera needs a bit of work. And then here's flags like main camera, billboard. I also have this macro, which just makes something slightly nicer. Well, not that nicer, but it just makes all of these new types. Texture instance is a U32. Time component comes an F32. We have a time res and we have a client time. So I'm just going to call it a time component. And then animated texture and texture component, which is actually a texture. So texture component is an actual handle to a texture. And then these are my kind of struct ones. I think some of these could become bundles, but at the moment I'm quite liking mixing and matching different ones. Let's see if this compiles then. So this just means that I can sort of consolidate down that code. I can ignore, well, I don't have to necessarily ignore the material system that I started the other day, but I think that's going to take shape a bit more now I've kind of done this initial exploratory work. So I'm going to wrap this up by basically getting different textures on those spheres. There is a task on the to-do list actually, which is about flipping the UVs, but let's see how this actually looks. Oh, that's supposed to be run. Okay, so we've got all of these. I'm not sure how that's actually compiling. Oh yeah, they're still there. So instance component, the instance buffer, instance component, parent, this little bundle instance as well. They also are stuff, things that might become a bit more like kind of solidified and reused. But what I'm going to do is go let text. I'm just going to load an array of textures. Which is going to be a texture component, and I'm going to load from file texture component device load from file. So what else did I have in there? So here's my textures. Not very inspiring. Blue checker 01. We may as well use the normal just because this can, in time, I can sort this out, get data path. And these ones are going to come from source data path. Oh no, actually, they already have DDS equivalents that I'm getting built. My mouse has had this tendency to click, like it's double clicked something, even though I've only made a single click. It's been driving me mad. Blue checker 01. Blue checker 02. I mean, I don't even have enough textures for blend test FG. Grab one of the bears. Oh no, he's already packed into another thing. So actually, a measly 4. That means that'll be 2. But at least everything will have a unique texture on it. So then we've got textures, texture component, and then we have a texture instance on the on here instead of a material instance. And then that needs an I, but we can work that out by Y. What is it? Y times IRC plus X. I think that is a 2D coordinate to a linear. and then textures need to be put into spawn. So for text in textures, and we need to spawn them into an entity just so it can hold on to them. If we keep them here and then we spawn entities with a reference to them, they're going to die, and that's, you know, it's going to drop when this function completes, and then we're going to, you know, run into trouble. So that's, again, I mentioned about it. Y as U size. That can be as U size. So yeah, memory management with the with Rust and GPU resources is kind of tricky. Let's get SRV index. So that's the index of the shader resource view. We're still failing, and it needs to be unwrapped. Still failing. Come on. That's as a U32. Ooh. Oh. Now we're missing everything. So my draw call for these guys now needs to change. Render meshes, push constants, material. This is going to become push constants texture. And I'll just see where this is referenced. My God. Mesh, push constants, texture. Push constants, textured. Mesh, push constants, material. Mesh, push constants, textured. I feel like I should change that as well. You know, it's never ending. Or should I call everything texture? Either way, everything should be called the same thing. Consistency is important. Mesh, push constants, texture. Mesh, push constants, texture. Mesh, push constants, texture. Mesh, push constants, texture. Render meshes, push constants, texture. And in here, render meshes, push constants, texture. So that's quite a lot of changes. I need to change this from mesh component. Well, so it needs a wall matrix, a mesh component, and it needs a texture instance. We still do the same thing. So this is set render heap. This is what I was talking about, binding the to the root signature and binding things on the heap. This goes on to slot 2 in the root signature, even though the register of the textures are on 0. And I'm going to improve that because the metadata in the shader knows that. So I'm going to try and make that a little bit more intuitive. So you're actually telling it which type of thing you're binding to and which register you think it's on. So then you don't have to really know about the descriptor layout. You know what you're putting in the shader, essentially. I think that'll be a bit cleaner. And that is has been causing a crash, which there's no error handling and there's no return from D3D itself. But I think through the pipeline and through the descriptor layout, I can actually validate that myself and prevent the crash from happening, because the render functions do return results and you can kind of safely and gracefully handle that. So push constants texture is the thing. This is going to be called texture. There's 2 at an offset of 16. There's only going to be 1, and that's texture 0, texture instance. This query has to change where it's registered. Render meshes push constants. Render meshes push constants texture. Still an error. This is wrong. This one, I don't even know if it needs to. We can just do that. I'm going to save all. And if this works and it loads complete, reloads complete, is it compiling? I'm not sure if the code's compiled. Right, it's still failing. But my shaders have compiled, my spheres have disappeared. A slice. Okay. Oh. So I can do this. GFX as U8 slice. Building. It hasn't crashed. Come on. Oh. Render meshes, push constants, material. What's looking for that? The render graph. It's not been updated. Might be something like I think potentially this hash hasn't updated. Render graph. Missing function. There is no render graph called that anymore though. I think there might be, that's a good shout. There's a stale, so because I deleted render meshes push constants material, it's not been removed. It's loaded in data and is still there. Removing render graph, or I suppose any state. From data is not removed from the live client. So that's another task. But now push constants, render graph mesh, push constants, texture. Come on. Eagerly. Still building. Oh yeah, cool. Amazing. Right, so now that looks a bit better, you know. It's like we've got different textures on there. They're being indexed. There's one bind. We're not binding textures, we just bind the heap. Potentially we can, so at the moment what's happening is the heap is being bound on each command buffer. So I think that has to happen. actually, that's fine. But yeah, so a bit of faffing around there. But I think it's important to kind of always sort of, this is called draw push constants material. Still, let me just rename all of that. Draw push constants texture. That's not even spelled correctly. Constants. There it is. Constants. Constants. Is it texture? Texture. Oh. Let's be consistent. Draw push constants texture. Mesh push constants texture. Draw push constants texture. Draw push constants texture. Set up draw push constants texture. What are we missing? Save all. Right, that's going to be it now. Oh no. Missing demo function, draw push constants material. That's fine because it's not there anymore. Just draw push constants texture. And so didn't hit any crashes actually, despite all of that like refactoring and jumping around. The client was still going. So I'm pretty happy with that. Yeah, so now the next thing is really like I was saying about in the draw API, there's little comments and there is a start of this like material system, but what it's going to be is potentially material ID or entity instance ID in vertex buffer. And we can do this with an instance batch. So you do a batch per mesh to begin with, and then cbuffer per entity, which is world matrix, and then instance ID and material ID maybe, and then a cbuffer per material, and then a shader that's going to look them up. And then also I'm going to look into, I said I'd look into that actually, so I'll just have a quick look. Set render heap. Set descriptor heaps. Set graphics root descriptor table. So, for example, these textures in that function render meshes push constants texture. We set the render heap on slot 2. And in the shader, debug JSON. Push constants texture. So in the descriptor layout, this is the first binding and it's on shader register 0, but we have to bind it on slot 2 because slot 1 is push constants 1, which is the view parameters, and slot 2 is push constants 2, which is the texture IDs. So that kind of offset is a little bit confusing to get your head around if this is abstracted away from you and you're just looking at the shader code where they're bound on slot 0. So what I want to do is to kind of bind it more, have the flexibility, add the ability to know I want to bind on 0 and it to actually put it onto 2. So I'm going to actually start looking at that next time, or maybe I'll do that beforehand if I get a bit of time. But anyway, I'm going to leave it there. Nice one.